So, ladies and gentlemen, for me to be able to get confidence interval of a single proportion, percentage confidence interval, this will be equal to the sample proportion, plus or minus the test statistic. For now, we are looking at large samples. So test statistic will be Z. So Z times what we call the standard who? The standard error. Z times the standard error. Yes, we have answered that. So percentage confidence interval equals sample proportion plus Z times the standard error. But now, how do we get, ladies and gentlemen, the standard error in situations where we have proportions? To get the standard error here, we'll be taking what we call P multiplied by Q all over N, like that, all over N. Ladies and gentlemen, this is quite important. The standard error equals root of P times Q all over N, And for you to understand what P stands for, what Q stands for, I would want us to look at an illustration. Let's look at an illustration. A sample of 600 accounts. A sample of 600 accounts. A sample of 600 accounts. A sample of 600 accounts was taken to test the accuracy. Was taken to test the accuracy of posting and the balancing of accounts. And the balancing of accounts where 45 mistakes were found. 45 mistakes were found. So they want us required to construct a 99% confidence interval of the population proportion with mistakes. So for us to be able to know the kind of audit, for example, the kind of techniques, audit techniques we shall be using, would want to know the population mistakes. Where do they fall? What magnitude am I looking at? So construct a 95% confidence interval of the population proportion with mistakes. Okay, I can see good questions over there. I'll go back there, don't worry. I'll go back there. Now, ladies and gentlemen, so we have here a sample. We could be a big company and we happen to be having so many ledgers. But of course, we can't go looking for the entire thing. We can't carry out a census. It'll be very expensive. So here what we have done, we've taken out a sample of how many accounts? 600 accounts. A sample of 600 accounts. And out of these 600 accounts, it's 45 of them that have got mistakes. So come and give me the sample proportion with mistakes. The sample proportion with mistakes. Give me the sample proportion with mistakes. So the sample proportion here with mistakes will be 45 out of what here? 600. So could you kindly give me this figure? What is 45 over 600? What is 45 over 600? I can see HP man giving me 0.075. 0.075. So then what do you think will be our Q? Remember that P plus Q must always add up to 1. P plus Q must always add up to 1. P plus Q must always add up to 1, meaning that Q will be 1 minus 0.075. 1 minus 0.075, which gives us, according to Denzel, 0.925. 0.925. Now, having gotten P and a Q, I expect you to go ahead and calculate for us the standard error. Calculate for us the standard error. Who is able to calculate that standard error for us? The standard error. The standard error. The standard error, ladies and gentlemen, the standard error. What do we have here for the standard error? The standard error in case of proportions, our standard error will be obtained by us getting a multiple of the 2, and then at the end of the day dividing like that. So we'll talk of 0.075 times 0.925. Whatever we get, we divide by 100, and then at the end of the day, we take not 100. We sampled 600 accounts. We worked with 600 accounts. We worked with 600 accounts. So our N is 600. So then could you kindly give us this standard error? Our standard error will be equal to what? So Nancy is giving me 0.011, quite a small figure, 0.11. Is there someone else who is able to get that 0.011? That's what I got personally. Even Samsung is giving us 0.011. The moment you have your standard error, ladies and gentlemen, then you are through with this particular arithmetic. Everything now becomes very easy. Everything becomes very easy. Ladies and gentlemen, here is where we are. So I will come and talk about 99% confidence level. 99% confidence interval will be equal to the sample proportion. The sample proportion. These errors are the ones that I would want to mirror. I would want to throw, and I have my population, or rather have a look at how my population looks like. So I'll talk of this Z times the standard error, which is 0.011. So of course here we are looking for Z because we are still tackling large samples. Our N is a whole 600. It's more than 30. It's more than 30. It's more than 30. So then, ladies and gentlemen, the most important thing that I would expect you to do for me, having realized that indeed would want to work with Z-score, please come and take this 99%. You divide by 2, have your entry figure. Somebody give me that figure, 99%, 0.99 divided by 2, 0.99 divided by 2. What do we have? Somebody there? 0.99 divided by 2, we have 0.495. Thank you very much. Once I have this 0.495, I would want you to go to your tables and read for us the corresponding Z score. Go to your tables. Go to your Z tables. Go to your Z tables and read for us the corresponding Z score. And read for us the corresponding Z score. The corresponding Z score. Read for us the corresponding Z score. So somebody is giving me a figure of 2.58, another one 2.57. Those are correct. All of them are correct. You can even go and get an average. Those are correct. Rounding off errors are acceptable. So let's work with 2.57. So once I have my 2.57 like that, I will come and give you the 99% confidence interval. This will be equal to the sample proportion. The sample proportion. The sample proportion you guys had given me, this thing that has got errors, 45 over 600, you gave me a figure of 0.075, 0.075, 0.075, plus or minus the Z score that you've been able to read, which is 2.57, times the standard error, which is 0.011. So could you kindly go ahead and give us the lower limit and the upper limit? The lower limit and the upper limit. Remember, to get the lower limit, what you'll do is to subtract. You'll take 0.075 minus 2.57 times 0.011. You subtract. So come here and give us the lower limit. Come here and give us the lower limit. What do we have here, somebody? Lower limit, you subtract. You take 0.075 minus 2.57 times 0.011. Please give us a figure. Somebody called HP is giving us 0.047, 0.047, 0.047. How about the upper limit? How about the upper limit? Upper limit we add. Upper limit we are adding. Upper limit you're taking 0.075 plus 2.57 times that. And according to 𝐂𝐿, we have 0.103. So meaning that we are 99% confident. We are 95% confident that the population errors will fall. The population errors will fall in between 4.7% to 10.3%. We are 99% sure. We are 99% sure that should these people go through all the accounts of the company, they are going to get the errors fitting in between here. I've just multiplied this by 100 in between there. So the upper limit and the lower limit, I want to believe that is okay. I want to believe that is okay with everybody. I want to believe that is okay with everybody, with everyone. Yeah, Nancy, I can see you're also confirming this figure, which is pretty much okay. This is okay. This is okay. This is okay. So mention there part B, difference between two proportions. Difference between two proportions. Difference between two proportions. So now we have here sample 1, and then we have sample 2. Sample 1 and sample 2. So we have our proportion. This could be 40%. This could be 45%. They have given us N. N here is 120. N here is 83. N is 83. N is 83. Ladies and gentlemen, these people want us to do something very easy. They want us to determine the 95 confidence interval of the difference between the two proportions. 95% confidence interval, 95% confidence interval of the difference between the two proportions, Very easy indeed. Very easy indeed. So the first thing that I will do here is to calculate the standard error. you calculate the standard error, bearing in mind, cognizant of the fact that now here we happen to be having how many samples? 2. We happen to be having 2 samples. So what you'll do, you'll come and tell us that the standard error will be equal to the square root of. These are things you'll have to just master. They're not hard. After we finish this and then we revise, everybody will be very okay. So we have here P1 Q1 over N1 plus P2 Q2 over N2, like that. So when you have these proportions, the only thing that you need to do, these are your P. So you need to come and introduce the Q's somewhere there, bearing in mind that P plus Q must always add up to 1. P plus Q must always add up to 1. Must always add up to 1, meaning 100%. Meaning that Q here will be 60%. Ladies and gentlemen, Q for this will be 55%. So this is what I will call P1. This is what I'll call Q1. This is what I'll call P2. This is what I'll call Q2, like that. Yeah, so come right away here and do your substitution beneath this. We have P1 is 0.4 times Q1, which is 0.6, all over N, which is 120. Plus the second one, we have P2 Q2. So we have 0.45 times 0.55 all over 83. So here you have to be quite good with your calculator for you to give us the correct answer. So for you to give us the correct answer, take 0.45 times 0.6 divided by 120 plus 0.45 times 0.55 divided by 83. You say equals. Whatever you get, you say square root. Whatever you get, you say square root. What figure are we going to get? What figure shall we be getting as our standard error? What figure shall we be getting as our standard error? What figure shall we be getting as our standard error? As our standard error. What figure do we have here as our standard error? What figure do we have here as our standard error? Somebody is giving me a figure of 0.71 or 0.071. Kiprotich, just check that figure. It's supposed to be 0.071. 0.071, that is my standard error. And once I have the standard error, ladies and gentlemen, I know if I'm the one doing this, the next thing will be about the entry and the Z-score. Entry and the Z-score. So how do I get the entry? I know that this is Z, because I can see how big my samples are. So being Z, what I need to do is to come and divide this 95% into 2. We divide 95% into 2. Divide 95% into 2. So when we divide 95% into 2, this will give us 0.47 what? 0.475. And for sure, this is what we call the entry. So get inside that table of yours. Get inside the Z table, inside the Z table, inside the Z table, inside the Z table, inside the Z table. Get inside there, the Z table. When you are inside there, in your Z table, you should be able, ladies and gentlemen, to read this 0.475 inside there, 0.475. So I can see it is here. I don't know whether you are you able to see my table? Are you able to see my table? Are you able to see my table? Yes. So I can see mine is here, 0.475. 0.475 corresponds to 1.9 something. 1.96. 1.96. So this is what I will take. No, they're not able to see my table, but at least they have gotten 1.96. So in this case, ladies and gentlemen, we have here the Z score. The Z statistic is 1.96. So once I have 1.96, then now I will be at home. I will be at home. I will come and give them the 95% confidence interval of the proportions. So I'll come and give them the 95% confidence interval of our proportions. So the 95% confidence interval of the difference between our proportions, which will be P1 minus P2, plus or minus the Z times the standard error that you guys gave me. So P1 minus P2, I can see it is 40% minus 45%. That is the same as 0.05 positive. Whenever you get negative, you disregard the negative. Dahir is getting a standard error of 7.02. 7.02. It can't be 7.02. Just go slowly, take 0.4 times 0.6. Whatever you get, you divide by 120. You say plus. You say plus. Again, slowly. 0.45 times 0.55 divided by 83. And then you say equals. And then ultimately, you should be able to get the square root of that. You should be able to get the square root of that. Once you do that, you'll be able to get that figure that the other students got. You'll be able to get the other figure that the other students got. Just try and see again. So I'm explaining here that basically we are looking at the absolute. We are looking at the absolute difference. We don't take into consideration the negative. We are looking at the absolute. We are looking at the absolute. We are looking at the absolute. And to imagine Dahir has been able to get it. And to imagine Dahir has been able to get that figure. And if that is the case, so we have a negative, but we are disregarding the negative. So we take it as 0.05 plus or minus the Z that you guys got, which is 1.96 times the standard error. Fortunately, the standard error, you have obtained it somewhere up there, 0.011. I can see Dahir saying, okay. So thank you very much, Dahir. At least Dahir is with us here. So 0.011. So come and give us the lower limit. Lower limit, you get the lower limit through subtraction. So you'll come and talk of 0.05 minus 1.96 times 0.011. You get an answer. Give us an answer, we write down the lower limit. So the lower limit, ladies and gentlemen, the lower limit at the end of the day will give us what figure for the lower limit. 𝐂𝐿. 𝐂𝐿 gives me a lower limit of 0.0816. How about the upper limit? How about the upper limit? How about the upper limit? Upper limit I'm being given, it is 0.199. 0.199, like that. So in short, our difference, expected population difference, expected population difference will be 8.92% all the way to 19.9%. 19.9%. You know, ladies and gentlemen, look at, for example, like the COVID samples. You'll get sample 1 of 3,000 people who have been tested COVID, having, for example, 7%, right, positive. Another sample of 3,000 having this particular. So we'll be asking ourselves, what if in this case here we were to get samples from the entire country, how different will these samples proportions be? The bigger the percentage, the more the errors. Because honestly speaking, given that we are drawing this population here from Kenyans, we are drawing the sample from Kenyans, we expect the sample differences to be closer to zero, And that is why when we go to hypothesis testing, you will see the ideal situation. We should be getting the lower limit being negative and the upper limit being positive, meaning that zero is in between. For now, just master it this way, that the difference, what we expect to be the population difference, will be falling in between there. For now, just master it that way. Dahir says, we have taken a wrong standard error. Or the standard error, thank you very much. The standard error that we got up there is supposed to be 0.071. Thank you very much for that. So will the answers change? Will the answers change? Will the answers change? Or you guys used the right figures? They'll not change. Thank you very much. I used a wrong one. Even for my people who will be watching this video, it's good to correct here, 0.0 like that. Now, ladies and gentlemen, write again another title. We are still talking of, no, in the limits, we don't ignore the negative. In the limits, if, for example, the lower, is the lower limit here negative? Is the lower limit negative? 0.05 minus 1.96 times 0.071. If it's negative, in the limit, you have to state negative. Where we normally assume positivity is here. So please, you have to state in the limits, the negative cannot be ignored. That negative is so important for us. That negative is so important for us in the limits. In the limits, for us now to understand this thing better, mention there, hypothesis testing dash single mean. Hypothesis testing dash single mean. Hypothesis testing dash single mean. Prayers. Yes, it's important. We go for prayers. So the students who will be left behind, I can finish that question that we started there of Excel. Is that okay? The students who will be left behind. Can we finish that question of Excel that we're working on? Thank you. So let me share with you the Excel. The Excel is here. So I want you to be very keen. I want you to be very, very keen. It's called index and merge. Index and merge. Very beautiful thing. Now, I want you to be very keen with this table that I have here. I want to be at a position of telling people Milan, Team Milan, comes from which country, whether it played the Champions League or not, how many games it played, and how many points it earned. So it's very easy. The first thing that I will do, I'll come and click on here, Milan, and a country. So I will come and say equals. When I say equals, I want to match. So how do I match like a soldier? You press M. Once you press M, you'll be able to see match is under blue. So if it's under blue, it means it can be tabbed. You tab. How do you tab? There is this particular button which is on top of caps lock. The one that is on top of caps lock is the tab button. So you press it like that, and then you'll be able to see match comes in the formula bar. So once the match is there, you can see where the cursor is blinking. It is telling me to ascertain the lookup value. So the lookup value is Milan. I'm looking for Milan. So once I say Milan, I will come and I'm just following this thing. By the way, Excel is the most beautiful thing. So I will come here and press comma because they want me to separate. So I press comma. So when I press comma like that, ladies and gentlemen, the next thing it wants me to do is to give them the lookup array. Remember, match normally matches just like a soldier on one column. So Milan, I'm looking for Milan on this column. So I need to come and highlight it. To highlight, there are so many ways. You could come and say Control Shift and then the down key. You highlight or you highlight the manual way, no problem. So I've been able to give them my array from cell B4 all the way to cell B12. Once I do that, I will come and say comma because I'm being directed here. Look up array, comma. From there, they want me to give them match type. Remember, match type, we don't want less than, we don't want approximations, we don't want greater than, we want exact match. We want to be told how many matches exactly. So I want a 0 there. What I'll do, I'll come and click on this exact match. Once I do that, I can see it's a blue ticked, blue label. If it's blue label, I'll come and tab. And then, ladies and gentlemen, I'll be able to say a shift, I close that bracket like that. Once I do that, what do? I'll say enter. When I say enter, this thing is able to tell me that Milan, it gives me the match, gives me the position, the row position. Milan is in row number 2 on this table. Milan comes after Borussia. Milan is here. But now, ladies and gentlemen, this really will not make a lot of sense to me. What first of all I need to do is to tabulate, to populate all these other cells. How do I populate? I have to come and fix a few things here so that the table doesn't move. The first thing that I would want to fix, please come here, is this column over the lookup value. The lookup value column has to be fixed. How do we fix it? Please go there. Once you have your cursor blinking, my cursor is blinking just before I, column I. Remember, column I is the one that carries my lookup parameter, which is Milan. So I need to fix it. How do we fix it? We normally fix it using the $sign. So $sign, I have to say shift. I have there button 4. The $sign. So you see the dollar coming before I. And then the other thing that I need to fix, these are things you'll be able to know. I need to fix my array. So please, for the array, come and highlight the whole of it. You highlight the array and be careful you don't highlight the comma. Once you have highlighted that whole array, I've been able to highlight the whole array. What I need to do as a shortcut, I can go the long cut of pressing $. The shortcut is to come and say F4. Once you press F4, you can see this thing has been able to put dollars because for the array, you do everything. So once you do that, ladies and gentlemen, again, you're finished. Give us enter. You can see this still telling me Milan is 2. So what I need to do is to come and copy that formula. So I'll go to this cell here. I say copy. Once I copy, ladies and gentlemen, I'll be able to drag this down a little bit, say Control, Shift, and then I have my right hand arrow. Sorry for that. So we can still go back here. Yes. So I want to copy this. The easiest way of copying it, we are here. So copy it there. So let us just drag usual. We drag like that, reach there. And once I reach there, now I should be able to say enter. When I say enter, I can see a lot of rubbish here. They are telling me Milan is row number 2 throughout. How about this thing called hamburger? This is a hamburger on this table. It is 1, 2, 3, 4, hamburger. Row number 4. I would want to put some sense into these figures. How do I put some sense into these figures? By indexing them. I would want to know Milan played how many games. So I would want to index them. Ladies and gentlemen, to index this, I will come just immediately after equals. I need to press index. Immediately after equals, put the cursor there. So when I put the cursor there, ladies and gentlemen, what I need to do is to come and press IN. Once I press IN, I can see my index function coming on top there. So once this index comes on top, that's blue. So I need to tab. Once I tab like that, I can see index coming, and it is giving me a cursor which is playing there, where they want me to give them the array. Which array? For index, the index that I want is to array the country. So I would want to tell these people where Milan comes from, which country. So I'll come to the country here. I would want to highlight these. You highlight like that, everything. Once you highlight like that, ladies and gentlemen, you're at home. The next thing that you need to do after array is to give us a comma. You give us a comma. The rows and the columns have been able to be taken care of by what here? By the match. So you don't press this row and match, row and the number column, whatever, no. So the only thing you need to do is to come and close your bracket here. So when you close your bracket there, you close, of course, here you have a red bracket. This red bracket goes together with this. But now I want the whole thing, bracket, black bracket. So shift, you press like that. And then once you finish, you say enter. When I enter, I'm being told that Milan comes from Italy. If Milan comes from Italy, ladies and gentlemen, no problem. I would want to populate the entire thing as I finish. So I'll come and cut, not cut, but copy. So I'll copy like that. I will copy like that. Once I copy, I will come and take everything like that. So ladies and gentlemen, I'll come and press enter. When I press enter, when I press enter, what am I able to see? I'm able to see something nice here, that Italy played the Champions League. Ladies and gentlemen, Milan, in this case here, or rather Milan played the Champions League. Milan played 38 games, and Milan, ladies and gentlemen, did what here? And 57 what here? 57 points. 57 points. I'm so sure these students have finished prayers. Are they back or not yet? I'm so sure they're back. They're back. They're back. They're back. They're back. Now, ladies and gentlemen, that index and the index and this thing of matching is something that an accountant should be able to understand and understand it very well. The index and match. The index and match is something that I would want to repeat severally for you to pick it and pick it very well, because there is no way you can tell me that you're an accountant and you don't understand the attribute of being able. You see, like you could go to an exercise where you are given like the Champions League, and these people have given you like say 500 teams. I need to know how I can extract information of Manchester alone. How can I be able to know, for example, how many points Manchester got? Out of what? Excel is a powerful tool. And because now we are here, I need to be guiding you slowly. Just 5 minutes, I give you a concept. And then, of course, after the class, ask for the data. The data that I'm using, you should be able to ask for it. Once I send it to you, and ensure that you're able to do that particular operation. By doing that, you'll end up being a very good accountant. Now, so mention there for us, hypothesis testing dash, single mean. Single mean. So once you have that down, I would want us to mention illustration. I'm almost clearing this area. It's a very sweet area, very sweet area, very sweet area. So mention there illustration. Illustration. Illustration, you are writing down illustration 1. The mean lifetime of a sample, the mean lifetime of a sample over 100 light tubes, over 100 light tubes, over 100 light tubes, like bulbs, eh? The tubes. Over 100 light tubes. So in short, they are telling us N is 100. Over 100 light tubes produced by a company, is found to be 1,570 hours. Is found to be 1,570 hours. With a standard deviation of 80 hours. with a standard deviation of 80 hours. With a standard deviation of 80 hours. Full stop. Test the hypothesis. Test the hypothesis. Test the hypothesis. Test the hypothesis. Test the hypothesis, which is a claim. A claim. Test the hypothesis that the mean lifetime. Test the hypothesis that the mean lifetime. Test the hypothesis that the mean lifetime of the tubes produced. Test the hypothesis that the mean lifetime of the tubes produced is 1,600 hours. Is 1,600 hours. 1,600 hours. 1,600 hours. And then they have told us that the level of significance is 5%. The level of significance is 5%. Write this in full. This is level of significance. Level of significance is 5%. Level of significance is 5%. This is very, very easy. Very, very easy. So how do we get started? Very easy. We state the hypothesis. So step number 1, state the hypothesis. State the hypothesis. Very easy. So the hypothesis, we normally have 2 claims. The first claim being the one of the null hypothesis. What we call the null hypothesis. So my null hypothesis here, what we shall be abbreviating as H0. H0. What we shall be abbreviating as H0, my null hypothesis says that my U will be equal to 1600. The null hypothesis is because they want us to test the claim. They want us to test the claim that the mean lifetime of the tubes produced by the company is 1600. 1600. 1600. So the null hypothesis is 1600. Now, ladies and gentlemen, remember they want us to test the claim that when we put up that bulb, it's going to stay there for 1600 hours. But you and I know that there is a possibility of this bulb either taking a lower duration or a higher duration. So it means that here we shall be carrying out a 2-tails hypothesis test. 2 tails because our hypothesis, null hypothesis, does not specify a direction. What they have told us, the claim they are making is the one of 1600 hours. So they are asking us to test the hypothesis that the mean lifetime of the tubes produced by the company is 1600 hours. Is 1600 hours. But we know that in reality, away from the claim, the tubes could stay up there, hung up there, either for less time or more time. So meaning that, ladies and gentlemen, we have what we call the alternative claim or alternative hypothesis. So the alternative hypothesis is what we shall be denoting as H1. And our H1 will be our lifetime. U stands for the mean. U stands for the mean. Our lifetime here could either be more or less than 1600. So in this case here, that our population mean is not equal to 1600. Is not equal to 1600. Is not equal to 1600. Ladies and gentlemen, if that is the case, I would want us first of all to define what a null hypothesis is and what, ladies and gentlemen, our alternative hypothesis is. So if we've written like that, mention their title, small title, null hypothesis, null hypothesis. Is that hypothesis, it is that hypothesis that is to be tested. It is that hypothesis that is to be tested. It is that hypothesis that is to be tested. That is to be tested for possible rejection. That is to be tested for possible rejection. That is to be tested for possible rejection or nullification or nullification or nullification under the assumption it is true. Under the assumption it is true. Tell us after full stop that a null hypothesis should always be precise. A null hypothesis should always be precise. Should always be precise. Such as the given coin is unbiased. Such as the given coin is unbiased. The given coin is unbiased. Or a drug is ineffective. Or a drug is ineffective. Or is ineffective. Or a drug is ineffective. Tell us there that the null hypothesis is usually assigned a numerical value. Is usually assigned a numerical value. Example, suppose we think that the average height, of students, is 150 centimeters, is 150 centimeters. Full stop. This statement, if taken as a hypothesis, it will form a null hypothesis. It will form a null hypothesis. It will form a null hypothesis. It will form a null hypothesis, which will be written as H0 U equals 150, which will be written as U equals 150. In other words, we hypothesize. In other words, we hypothesize that U equals 150. We hypothesize that U equals 150 centimeters. So we are saying, somebody is telling us that, for example, when you come to RCM, when you come to Summit, all students have a height of 150 centimeters. I mean, crazy. That's a hypothetical. It's not possible for us to have all the students in this case here having the same height. Hypothetical. So it's a claim that we must come and test. And for us to test this, we need an alternative. We need an alternative. So for the alternative, listen and listen to me very well. For the alternative, which we'll be calling H1, there are three possibilities. It is either you'll tell us U is more than 150, or you tell us U is less than 150. Or you tell us U is not equal to 150. So one thing I would want you to appreciate from the word go, when I go to summit there, trying to assess the heights of the students. The students that I'll get will be taller than this. Other students will be what is shorter than this 150. So meaning that the proper alternative hypothesis that we need to put down is this one here, is this one here. So give me a title there, the alternative hypothesis. The alternative hypothesis. Tell us there that this is the claim that will be accepted. This is the claim that will be accepted. That will be accepted if the null hypothesis, if the null hypothesis, if the null hypothesis, if the null hypothesis is false. 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 So please let us go back to the question that we were doing. Let's go back to the question that we were doing, ladies and gentlemen. What we have here with yourselves is a situation where some manufacturer is making some quite a crazy claim. He's saying that when I give you my bulbs, these bulbs, population, all of them will hang up there for 1,600 hours. So as now we've gone there, but before we buy, we need, ladies and gentlemen, to test the claim hypothetically. So then I know that for sure, not unless there is anything that will be able to prove me otherwise, I know that these bulbs, some of them will take longer, others will take shorter. So my alternative claim, ladies and gentlemen, will be U is not equal to 1,600. Why? Because I appreciate the fact that there will be some bulbs will be more, take more time. The other bulbs will take less time. So this is my alternative hypothesis. Step number 2, ladies and gentlemen, given that this is a large sample, come and give us the Z critical. Give us the Z critical. Give us the Z critical. So Z critical, we have to draw our good diagram. So our good diagram, remember here, this examiner has given us the level of significance. He has told us that the level of significance happens to be 5%. 5% happens to be 0.0 what here? 0.05. Ladies and gentlemen, the moment you give me level of significance, given that this one is a not equal, given that it can go either way, there are two directions, it means that you are handling a two-tails test. It's not a mono-sided figure. It's a two-tails test that we have here. Two-tails test that we have there, meaning that this level of significance must be divided into two. The level of significance is like this. The level of significance has to be divided into two. So come and take there alpha over 2. So alpha over 2, what is 0.05 divided by 2? What is 0.05 divided by 2? 0.05 divided by 2. That one will give me what figure, my great students? 0.05 divided by 2. I'm not getting your figures. Somebody is giving me a figure of 0.025. So somebody is giving me 0.025. Now, ladies and gentlemen, listen and listen to me very well. Once you have gotten that, you need to come and give us this area which runs from here all the way to there. given the fact that the half area is 0.5, given the fact that the half area is 0.5. So I need to get this one here. So this one here will be 0.5 minus 0.025. Can somebody give me this answer? Remember the level of significance, unlike the confidence interval, the level of significance normally goes to the tails. Normally goes to the tails. So now I want to get the area which runs from here to here, what we normally call the entry now. What we call the entry. Lokai, Samuel, Maingi, these students are giving me 0.475. Once I get the entry, I need now to use the reverse gear where we get inside the table and read outwards. Read outwards for us to be able to get the Z score. I want the Z score. I want the Z score. I want the Z score. You go inside the table looking for 0.475. So Lokai is giving me a figure of 2.57. Please look at this. What are we doing? We are getting into our normal tables. Our normal tables, our normal tables, our normal tables. Ladies and gentlemen, we should be able, this is the entry, the one that runs from here to the upper limit is the entry. So once you have gotten the entry, somebody ensure that you are able to see the 0.475 inside that table. The 0.475 inside that table so that you will be able to give us, ladies and gentlemen, the entry figure. So the entry figure, what do we have? 0.475 is the entry. How about the Z? Is there someone else who is able to see 2 they've changed language. Nancy, Samuel, they're saying 1.96, which is telling us the truth, which is cheating us. And of course, if there is a disparity, truth, cheating, then we need to do a hypothesis test. 1.9, even Lokai has changed her mind. She's telling us that the Z here should be 1.96. Now, ladies and gentlemen, the moment we have that 1.96, listen and listen to me very well. Unlike confidence interval, here I will have 1.96 positive on this side. On the other side, I'll also have 1.96, but because it's on the left-hand side of the mean, I have to come and put a negative there. I have to come and put a negative there. So kindly put a negative there. Kindly put a negative there. Put a negative there, and then now that is it. So now you need to move to the last area. The last area is quite a nice area. Last area, or rather before I go to the last area, I want you to indicate there that this unshaded region, the unshaded region is the H0 region. H0 region. The shaded ones, these are the H1 regions. Shaded ones, they are the H1 regions. Okay, so how do we get this 0.475? Very easy. Kumbuka kale kahesabu kamluya, kale kahesabu kamluya kuna kumbuka vizuri. Hapa kama uko na 0.025. I hope you saw where we got the 0.25. We know that this entire area is 0.5, I mean. And therefore, to get this area alone, given that the two must add up to 0.5, to get this area alone, you will take the 0.5, you subtract 0.025 like that. So if you do it that way, you'll be able to get that 0.475. I hope Zamzam now you, thank you very much. Great. So and I hope the moment you've been able to see where we got the 0.475, you'll be able to see where we got the 1.96 from the tables, Now with this 1.96, I've said you must go to the other side and mention there 1.96 albeit with a negative. Now, ladies and gentlemen, the moment we hit there, now we'll go to the last stage. The last stage is the one where you mention there the Z calculated. So mention there Z calculated. So Z calculated. So go ahead and mention Z calculated. So for the Z calculated, I know we are so much used to our normal Z. Well, we normally say that our Z is X minus mu. X minus mu all over who? Standard deviation. This time around, you're not going to make use of this. Our Z calculated, our Z, so not this one. Our Z calculated will be X bar minus mu. And because now here we are working with X bar, we have many samples X bar. Now we'll talk over what we call the standard error. So please write that. Our Z calculated is X bar minus mu divided by standard error, divided by standard error, divided by standard error. I'm repeating again that for us to be able to get this Z calculated from our sample, our Z calculated, you're repeating again, Z calc is X bar minus mu all over standard error. And don't forget that to get standard error for a single mean, normally what we do is to take the standard deviation given, divide this by the square root of n. Could you kindly calculate that for me and then you give me an answer? Kindly calculate that for me and then you give me an answer. Tell me what do we have there. Yes, I'm waiting for my students here to give me an answer. They're telling me that the standard deviation that has been given in the question, the standard deviation given in the question is 80 all over square root of n, which is 100. So this will give me 10. So 80 divided by 10 is 8. So once I'm there, ladies and gentlemen, I'll come and plug in here. So X bar, what is our X bar? The X bar, remember we went ahead, X bar is the sample mean. Please write somewhere there that X bar is a sample mean. X bar is the sample mean. X bar is a sample mean. And our X bar, ladies and gentlemen, the sample mean, the one that we sampled is 1570. So we have here 1570 minus the mu, the population mean. The population mean, the one that is being tested, is 1600 all over the standard error that you guys got. The standard error that you guys got correctly, which is 8. So could you kindly give me this Z calculated? Give me the Z calculated. Give me the Z calculated. Could you kindly give me the answer? The Z calculated will be equal to what? Somebody is giving me a figure of minus 3.75. Minus 3.75. Thank you very much. Thank you very much. Now, ladies and gentlemen, from there, come and place this Z calculated figure on your diagram. You have your number line here. Tell me whether it falls on a shaded area or whether it falls on unshaded area. This minus 3.75, where does it fall? If this is my number line, of course I know at the middle here I have a 0. As I go that way, so of course I can see minus 3.75 will fall here. Minus 3.75 will fall there. And if it falls there, ladies and gentlemen, what do we have? If it falls there, ladies and gentlemen, we can see that this falls on shaded area which is a H1 area, which is a H1 area. All shaded areas are H1 areas. All shaded areas are H1 areas. They are H1 areas. So, ladies and gentlemen, the moment I've been able to hit there, I'm telling the examiner that therefore we can only accept H1. We can only accept H1. We can only accept H1 because we have fallen on the H1 area. So we can only accept H1, meaning that the null hypothesis is not true. That manufacturer who was claiming that his bulbs will be able to stay up there lighting for 1600 hours has cheated us. Ideally, we expect what here even much fewer hours. We expect much fewer hours. We expect much fewer hours because it has fallen on the left-hand side. So, ladies and gentlemen, I would want to open this session into a Q&A. Q&A session. So I expect you guys to ask questions because I can't teach more than that. For one lesson, I'll invite trouble. Once you have that particular footing very well, I'm so sure now in the subsequent classes, you'll be able to understand everything very well. So ask any contribution. Ask questions kindly. If